Question number 4 seems to be chemistry of copper, which is to do with transition metals. So this is a fixed case study. You can watch my A-level concept tutorials. Is it in there? No, probably in the experimental tutorial playlist, where I've actually shown and demonstrated these reactions, a series of experiments, series of ligand substitutions, where you could actually see the color changes rather than just, reading books and knowing all these color changes just by reading. It's better to have seen it. Ideally speaking, in the real world, you should have done these experiments and you learn by doing, and that's the best way to learn chemistry. Alternatively, in light of COVID, if you can't go to the lab, you can watch my experimental tutorial videos. Perhaps that can help you to some extent. So what we have here is we have copper 2 plus aqueous ion is actually copper hexa aqua complex. So this is equal to copper 2 plus aqueous. What we have excess sodium hydroxide. So our color and state, they want two things. They want color and state of the copper species. So the color is going to be a pale blue, and then it's a precipitate. So precipitate means it's a solid. Okay, so I have described the color and I described the state as well. Ionic equation. Ionic equation must have stat symbols, whether they ask you to or not. So what actually happened is the copper H2O6 2 plus aqueous plus the 2OH minus aqueous. What happened is you get copper hydroxide as a precipitate, and there will be a solid, and it will kick out the water, which is going to be liquid, and they don't dissociate further. So this is a precipitation reaction, and this is what you have done for precipitation ionic equation. It's just adding in the water as a result of kicking out the 6 monodentate ligand there. What type of reaction is this? This is a precipitation reaction, as you are forming a precipitate from two solution. This is a pale blue solution. This is a colorless solution. You get a pale blue precipitate, insoluble in excess NaOH. Part 2 is about with excess ammonia, excess aqueous ammonia. So what is going to be the color and the state? Well, you are going to, first of all, actually you're going to get this thing, which is a pale blue precipitate. However, ammonia in excess can act as a ligand. So this thing can act as a ligand and replace the OH minus, such that you get copper with 4 ammonia. So it's an incomplete replacement, unlike with cobalt. So this is just 4 ammonia but 2 water, so it's still octahedral complex. Each of these ligand has no charge, so it's still copper 2 plus like that. They are asking for the color, so they are not asking for this thing. That is actually for the next bit. So the color of this is actually a dark blue, and it's a solution meaning aqueous state. Okay, they want the color, they want the state. Now I need the ionic equation for this thing. So what happened is I started out from copper H2O6 and then 2 plus. I have 4 NH3, and I will get this particular dark blue complex. And what happened is I only kick out 4 water. I only kick out 4 water and replace them with ammonia. So I still have 2 H2O there. Okay, so let me get rid of that. I don't know what happened there. Okay, so I kick out 4 H2O. Be very careful to write your equation balance. 6 water give you 2 water remaining. So you kick out 4 water, only 4 ammonia replace 4 of the water. It's an incomplete substitution to give you that dark blue complex. It's a feature quite special and quite unique to the copper chemistry. And this type of reaction is no longer a precipitation because all of these are aqueous. Pale blue solution, colorless solution, dark blue solution, and liquid water colorless solution. Well, colorless liquid, not a solution, because all of these are dissolved in water. You can watch my experimental tutorial video playlist, especially on the one on copper 2 chemistry, where I demonstrated these color changes. So these are ligand substitution reaction, where we have substituted one ligand, which is the H2O, with NH3 there. To the next part of the question. This seems like a very, very short question actually. So part B, we have copper 1 oxide. Be very careful. Copper 1 oxide would mean that you have Cu plus and O2 minus. So the valency there is 1 and 2. So when you cross multiply it, you're going to get the LCM. This means copper plus, and you're going to get O2 minus, Cu2O. This is going to be copper 1 oxide. So be very careful with your formula. I'll probably copy paste this onto a new page because I don't want to run out of space. So what do we have here? We have copper 1 oxide, Cu2O, reacting with H2SO4, which is sulfuric acid. You get a blue solution. By the way, this is actually a brick red PPT because this is the PPT that you get when Fehling reagent reacts with aldehyde. Think about Fehling reagent is pale blue solution. And then when you have aldehyde, if aldehyde is present, you're going to get brick red PPT. And that brick red PPT is copper oxide. Copper 1 oxide specifically. So there's brick red solid plus that. You're going to get a blue solution. Very clearly, the blue solution will indicate the presence of copper H2O6, meaning copper 2 plus aqueous. And you get a red-brown solid. Unfortunately, I said this is a brick red PPT, but you also get a red-brown solid, which is actually not going to be... what am I talking about? Let me think. What is this? I think the red-brown solid is not going to be copper 2 oxide because copper 2 oxide is actually kind of black in color. So CuO is black. CuO is a black solid. So meaning to say this brown color precipitate, this red-brown solid, it's not likely to be the copper oxide. I think it's going to be copper metal. But copper metal is usually described as a pink or salmon kind of color solid. Let me just try and balance this equation from scratch first. Copper 2 oxide plus H2SO4. So I get CuSO4. And I can get copper. And I can get water. Is that correct? Probably. So the copper SO4 can dissolve in water to give me the blue solution. I have 2 copper, 1 goes there, 1 goes there, sulfate there, H2 goes there, O goes there. This is the complete balance equation, so this seems legit. Copper to sulfate and water, so these two together will give you the blue solution. So my hunch is kind of correct that it has got to be copper, which is the red-brown solid there. So X is the blue solution, so there is copper to sulfate, aqueous, and then Y is going to be copper solid. This is actually going from copper plus 1, copper 1 oxide, to copper plus 2, copper 2 sulfate, and copper 0. This is what we call, it's not really disproportionation, but it's kind of like reverse disproportionation. No, actually it is disproportionation, sorry. Disproportionation because it is one species is both oxidized and reduced in the same reaction. Plus 1 to 0, that is reduction. And then plus 1 to plus 2, that is oxidation there. Plus 1 to plus 2 is an increase in oxidation number, that's oxidation. So this reaction is called disproportionation. That's the end of the end mark question there.